So as we've discussed the first portion of the pentose phosphate pathway, also known as the oxidative phase, where we oxidize glucose to ribulose 5-phosphate, or well, 3-glucose to 3-ribulose 5-phosphate molecules. What I'd like to do now is begin stepwise and in kind of in a piece-by-piece way, build on the non-oxidative phase, or the second portion of the pentose phosphate pathway. So as a review, here's our entire pathway. This first portion at the top, we've already discussed. This is our oxidative phase. Now, everything else constitutes our non-oxidative phase. Our oxidative phase is where we generated our NADPH, which is one of our two major components, and our non-oxidative phase, where we're not generating any NADPH, but instead what we're doing is we're developing and generating more of this ribose 5-phosphate, or generating our second major molecule, ribose 5-phosphate. What we're going to do is get into kind of the bits and pieces of this. Okay, so at the end of our oxidative phase, we end up with ribulose 5-phosphate. Now, we don't end up with one molecule of ribulose 5-phosphate. Instead, we end up with a grand total of 3 ribulose 5-phosphate molecules. Those molecules are going to undergo processing, 2 of which are going to undergo an epimerization, and one of them is going to undergo an isomerization. Now, if you look at these molecules and you remember the terminology, an isomer is the exact same molecule, but with the different or with atoms positioned in a different fashion. So the same composition, but atoms and functional groups positioned differently. An epimer, well, if you remember what epimers are sugars that are related and are basically identical, except for the positioning of a hydroxide group about one single carbon. Now, here are our two products that are going to be generated. This ribulose 5-phosphate, one ribulose 5-phosphate molecule is going to undergo an isomerization. The reaction is going to be catalyzed by Ru5P, or ribulose 5-phosphate isomerase. What we're going to have is we're going to take our position, our carbon number 2, which is our carbonyl carbon. That's going to now be carbon number 1. Our carbonyl carbon is going to move up to the 1 position. Okay, so ribulose 5-phosphate isomerase is going to catalyze that reaction. Now, not necessarily in the opposite direction, but the other reaction that will be taking place is we're going to have Ru5P epimerase. So ribulose 5-phosphate epimerase. That ribulose 5-phosphate epimerase is going to take carbon number 3 right here and right here and epimerize both of those. So move our hydroxide group from the right-hand side to the left-hand side. And in the process, we're going to make a molecule known as xylulose 5-phosphate. So if you wanted to think about these as simply put as possible, the ribulose 5-phosphate isomerase is taking a ketose and making an aldose. Whereas ribulose 5-phosphate epimerase is making a C3 epimer of ribulose 5-phosphate. So this is our first step into kind of our cyclization or our non-oxidative phase. Now, if you think back to the general overview of the pentose phosphate pathway, what are we trying to generate? We're trying to generate NADPH and ribose 5-phosphate. Arguably, at this point, we've generated our second of our major components, our second of our major products. But that's not the end of that. That's just kind of dipping your feet into this kind of cyclic pathway of the of the pentose phosphate pathway. I hope this is helpful as you begin to look at those different enzymes.